Good morning. For the next hour, this panel will look at how NASA and Hollywood use advanced technologies and inspire one another.
We'll start this part with the curious and relevant question. Why haven't we gone back to the moon since 1972? This question, I can say, collided with this extremely bizarre answer given by the same NASA official who had told us, with his knowledgeable fellow astronaut, about space in part 1.
Go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again. But going to Mars should be one of the next series of steps that humans. The only limit to a human future is in our own imaginations.
So, we could go to the moon in a nanosecond, but we destroyed this technology. What technology did we have that let us travel space distances in nanoseconds in 1970s? Teleportation? And we destroyed it? You mean like this? What the heck is he talking about? But let's just say that he had a really tough night, and what he meant in fact was we destroyed that technology. And let's just even say that by destroyed he meant lost. Even then, we face a very odd question. How could we lose the technology from 1970s, which was far more advanced than today's technology? You mean this miracle of engineering with the computer processor as powerful as in this calculator? But the most striking part of this utterance should reveal itself when we read between the lines.
The only limit to a human future is in our own imaginations.
So, the only limit to our future is not some technology, existing or lost. No, it's NASA's imagination. The second issue is also connected with NASA's incredible negligence. Did you know that all telemetric data from the Apollo missions has been lost? This is what a NASA archives attendant told journalists who actually wanted to prove to all skeptics that we did land on the moon.
Right. We've been unable to track it down. I mean, we don't know where this telemetry data ended up, and we don't know what path it may have taken. So, unfortunately, I'm afraid I can't really give you much of a clue as to where this data ended up and whether it still exists or not.
Another NASA official confirms that.
I haven't seen anything that indicates the telemetry data is even in existence, and as I said, even if we had it, we don't have the machines to play it back.
But your own research has shown the telemetry data is missing.
That's right.
Shouldn't the data from the moon missions be the most precious thing in the human history? We have managed to preserve the original historical documents and the abundance of art, but there is no trace after the materials from the most difficult achievement in the entire known history of the humankind. The explanation I came across doesn't help much. It says NASA may have erased the original tapes due to a major tape shortage. Right. The last question in this part concerns the radio communication time delay. How long is it? Let's see what the time delay is when universities talk to the ISS.
Okay, here we go. Hello, Commander Fisher and Commander Whitson and Colonel Fisher. It is an honor for all of us and those online to join you and all of your colleagues at NASA in the first ever live 4K stream from space. What is the ISS position in orbit right now? 11 seconds.
just passing over Baja, California, and we're heading in an arc over North America. By the time we finish talking, we'll be over Central Africa.
Wow. Amazing. Amazing.
First of all, why does it take so long? 11 seconds? Secondly, they both clearly nod, agreeing on 11 seconds.
11 seconds. 11 seconds.
11 seconds.
And thirdly, this is very nice, the gentleman reacts instantly to the cheering of the audience.
Wow. Amazing. Wow. Amazing.
And this kind of time delay in turn occurs when terrestrial musicians want to sing along with the ISS crew.
Indeed. Your scenery looks a little nicer than ours. Have you a rusty floating guitar pick with you? Excellent. Mine is subject to gravity. Yeah, I know, yours matches your mission patch. Gleeks, are you guys ready to do this? Yeah! Chris, ready to go?
Yes, Ed, I'm ready.
Okay.
Let's do this.
Let's do it.
And orbiting in space, push back in my seat, look out my window, there goes home.
And here in turn we see the time delay when President Trump has a chat with space.
What are we learning by being in space?
Well, I think probably the International Space Station is providing a key bridge from us doing living on Earth to going somewhere into deep space. So
space is like. Could you share what a typical day looks like, what the challenges are, just any special moments?
Well, a typical day, we wake up and look at the messages from the ground.
It is about 3.5 seconds. However, the time delay lasts only 1/10 of a second when Donald Trump asks who a volunteer for the first Martian mission is.
Who's ready to go to Mars up there?
We are absolutely ready to go to Mars. It's going to be a fantastic journey getting there. And
the instant reaction is better visible from another, apparently an amateur camera.
Who's ready to go to Mars up there?
So, like in part 1 about stars, here you can choose 2. This time you can choose about how fast sound travels to the ISS. 1/10 of a second, or 3.5 seconds, or maybe 11 seconds. Summing up, we are going to Mars, though we can't go to the moon. NASA has erased the moon tapes for more important stuff, and the speed of sound depends on the person who speaks or sings and on exact words. Songs, funny stuff, questions about Mars travel much faster than regular conversations.
Wow.